So today we're looking at substitution, and this is section 7.2. Okay, so this time we're going to solve a system of equations using an algebraic method. In the last video we solved it using graphing, but this is an algebraic method. So take a minute and write down all of these steps, and then we will talk about them. Okay, but first just pause the video and write them down. Okay, so let's go through one with the steps and you'll see what we're going to do. So the first step says to solve one equation. First thing we got to do is write them side by side. So we're going to go ahead and write these next to each other. Back it up. There we go. That's better. Y equals 3x and x plus 2y equals negative 21. Now we want to solve one equation for one variable. In other words, isolate either an x or a y. In this case, the y is already isolated here, so we're set to go. So we're going to substitute the expression for y, which is 3x, into the other equation. So in place of y, I'm going to put the expression that equals y. Now I'm going to solve step 3, solve the second equation for the second variable. So x plus 6x equals negative 21, 7x equals negative 21, and x equals negative 3. Again, pause if you need to watch. Then the next step says to substitute this value back into the first equation. So y equals 3 times negative 3, and y equals negative 9. So my final answer is an ordered pair, negative 3, negative 9. And if I were to graph these two equations on a graph paper like we did in section 7.1, you would see that it intersects at the point negative 3, negative 9. It's always a good idea to check, so let's look at y equals 3x. If I plug in negative 9 for y and negative 3 for x, that does in fact work. This is our check. And if I use my other equation, because it's got to work in both equations, not just one, if x is negative 3 and y is negative 9, this also works. Okay, let's try another one. Writing them side by side. And my step is to solve one equation for one variable. I'm always going to look for the variable that's all by itself. So I'm going to solve this left-hand equation for x. X equals negative 5y minus 3. I subtracted 5y from both sides. Now I'm going to take this expression and bring it over here. This is why I write them side by side, because I can go back and forth. So 3 times, instead of x, I'm going to use my equivalent expression. Write the rest of the equation down. Negative 15y minus 9 minus 2y equals 8. Combining my like terms, adding 9 to both sides, I get y equals negative 1. It would probably be helpful if you would write this down once and then go back and listen, or just listen through and then write. So now I've solved the second equation for the second variable. I'm going to substitute this back into this side. So x equals negative 5 times negative 1, that's the value I just found for y, and minus 3. So x equals 5 minus 3, which makes x equal to 2. So my point of intersection of these two equations is 2, negative 1. And again, you can check this in both equations. It will work, so we have the right solution. Okay, you might want to pause and look through both of these a second time, but I'm going to have you try a couple on your own. So pause the video and try this one on your own, and then come back. Okay, again, we're going to write these side by side. This time it looks like this is going to be the easiest variable to isolate. So I'm going to subtract 3y from both sides. I'm going to then take this and put it in over here in place of the x. Whoops, I'm sorry, that should have been plus 9. Got too many equal signs in here. And minus y equals 4. So negative 6y plus 18 minus y equals 4. Combining my like terms and then subtracting 18 from both sides, I get y equals 2. I'm going to put this back into this side. X is, bringing this one down, negative 3 times 2 plus 9, so x equals 3. So my solution here is 3, 2. I hope you got that. We can, again, go back up and check. When you're taking a quiz or test, you can always check, plugging in your x and y ordered pair. So 6 minus 2 is 4. And checking that in the other equation. So plugging in 3 for x, 2 for y. And again, this works as well. Okay, I'm going to give you one more to try on your own. So try this. Okay, this one was a little different. 6x minus 2y equals negative 4. Y equals 3x plus 2. So this one is already solved. All I have to do is bring this over and substitute it for y. And I got 6x minus 6x minus 6x, minus 4 equals, oh, I see what I did wrong. I copied it. I couldn't figure out where that 4 came from. My bad. Here we go. Negative 4, negative 4. 6x minus 6x is 0. That doesn't seem like a very good answer. Let's think about this. If negative 4 equals negative 4 is a true statement, that means that no matter what value I put in for x up here, this is going to be true. So there are an infinite number of solutions to this one. We'll do a couple more of these in class, and I'm going to show you on a graph how this works as well. The last one is a word problem. A metal alloy is 25% copper. Another metal alloy is 50% copper. How much of each copper should be used to make 1,000 grams of a metal that's 45% copper? So I have two pieces of information, total grams and percent copper. So this is going to be equation number 1, and this is going to be equation number 2. So since I'm looking for the total grams, how many grams of each alloy, I'm going to assign the variables for grams. So x is going to equal the number of grams for the first alloy, and y will be the number of grams for the second. So the first thing I know is that they have to total 1,000 grams. So x plus y has to equal 1,000. And then it also has to be 45%. So now I'm dealing with my percents. So 0.25% of x plus 0.50% of y has to equal 0.5% of the total, which was 1,000. So that's the system. I'm going to let you try this one on your own. We'll talk more about the setup of the equation in class, and we will see if you came up with the right answer in class together. All right?